Hi, and welcome back to our chemistry flipped classroom. We are continuing our lessons today on nomenclature, on how we name chemicals from their formulas, as well as how we develop their formulas from their names. So yesterday we talked about naming ionic compounds with metals that always have fixed oxidation states. And we were naming binary compounds, meaning it was just one metal and one non-metal. So we're going to continue with naming binary compounds, so just a metal and a non-metal. But now we're going to move into transition metals. And naming these is different because these metals have multiple oxidation states. So when we were talking about group 1 and group 2 and group 3 and even zinc and silver, those metals always have the same charge. Group 1s are always +1, group 2s are always +2, group 3s are always +3, silver is always +1, and zinc is always +2. But some metals form more than one cation. Most of the transition metals can have multiple oxidation states, which means that they can sometimes be an ion with one charge and sometimes be an ion with a different charge. The one thing that we know is that they're always going to, when they form ions, have positive charges. So we can't simply name these and expect that people will know the charge the way we do when we name, say, calcium chloride. We know that calcium is always +2, but we don't know that with a type 2 metal. And so we have to use a Roman numeral when we name these. And so we're going to look at the formula and we're going to determine what the charge is. So here we have PbCl2. We know that chloride is a -1. There are 2 of them. That means that our cation must be lead with a +2 charge so that this compound is neutral. So when we name it, we want to explain that its charge is +2. And so we name it lead 2 chloride, with the 2 being Roman numerals in parentheses. So in order to name these, we have to figure out first what the charge of the cation is. And we're going to do that by looking at the charge of the anion. And then we have to name the metal, and then a Roman numeral showing its name, its charge, and then the name of the anion. Okay, so when we name these, first we name the cation, then we name the anion, and on our cation, we're going to give the name of the element plus its charge in Roman numerals. So here our example is that we have the iron 2 ion, and so we're going to, it's Fe2+, so we're going to name it iron 2. We're going to change the ending of our anion from ine to ide, and we're going to have iron 2 chloride, and that 2 is necessary so that when we read the name iron 2 chloride, we know that this is iron with a charge of +2. This does not mean, as you see here, that there are 2 irons. This means that the charge of iron is +2, which then means that we have 2 chloride ions. All right, so let's practice naming these. So the first one, we look at our periodic table and we see that Au is gold. And then we look at our periodic table and we see that sulfur, when it forms an ion, is the sulfide ion, and it has a -2 charge. Because it has a -2 charge and there are 2 gold ions, we know that each of those gold ions must be +1. So we're going to name this gold 1 sulfide. We're also going to look at this next one. We see that we have iron and oxygen. We know that oxygen is -2. There are 3 of them, so that means a total of -6 here, which means that my iron must have a total of +6. So each iron, since there are 2 of them, must be a +3. So I'm going to name this iron 3 oxide. We're going to move on and do a couple more examples. So here we have titanium and bromine. You see that we have 2 bromides. We know that each bromide ion has a -1 charge, and there are 2. So that's a total of -2, which means that titanium must be +2. And so we would name this titanium 2 bromide. And the last one we'll do as an example is titanium. And then we have oxygen, and we have 2 oxygens here. We know each oxygen is -2, so that means this is a total of -4. It's with only 1 titanium, so that means that this is titanium 4 oxide. So I would suggest that you pause the video now and you try to write the names for each of these formulas, practicing as we have been. Then we're going to move on to the next slide, and I'll show you the answers. I'll also post the slides on our SaintsNet page. So we have gold 1 sulfide, iron 3 oxide, titanium 2 bromide, titanium 4 oxide, and moving on, scandium 1 nitride, and on down through the list. All right, what if we need to write a formula? So now we're given the name and we want to write the formula. So we've been writing names from formulas. Now we want to write formulas from names. So we're going to write the cation symbol first and then the anion. And we're going to use the Roman numeral in the name to determine what the charge of the metal is. And we're going to use the periodic table to determine what the charge of the anion is. So if we're given vanadium 5 chloride, we know that vanadium 5 must be a +5 ion. We look at the periodic table and we see that chloride is a -1 ion. So that means that I'm going to need 5 chloride ions to go with my 1 vanadium ion. And so I'm going to write VCl5. And we're using that subscript to show that we have 5 chloride ions to balance that +5 charge from the vanadium 5. So we'll do this the same way. We're going to write a couple of the formulas together, or I'll walk through a couple of the formulas, and then I encourage you to pause the video and practice writing the formulas for yourself, and then unpause and come back and check the slides. So we have iron 2 chloride. We know that iron is a +2. Chloride is a -1. So that means I need 2 -1s to go with my 1 +2. So I would write this as FeCl2. Now I have nickel 3 sulfide. From the 3, I know that nickel is a +3. I know that sulfide from the periodic table is a -2. So I need 3 -2s to go with 2 +3s. So I would write Ni2S3. And one last one, chromium 1 is going to have a +1 charge. Fluoride has a -1 charge. So I'm just going to write CrF. So here are our answers to our example problems. As always, if you have any questions, please let me know. I look forward to seeing you in class tomorrow.